Hi, good morning. Today we will see classification of heat exchangers. Let us go to the definition of heat exchanger first. So, what is heat exchanger? Heat exchanger is defined as heat exchangers are defined devices that facilitate the exchange of heat between two fluids that are at different temperatures. So, we can say that heat exchanger is a device. Heat exchanger is a device in which two fluids will be there. Two fluids will be there. So heat exchange will be takes place in these two fluids, and these two fluids will be maintained at different temperatures. So the fluid which is maintained at high temperature is called as hot fluid. The fluid which is maintained at low temperature is called as cold fluid. So heat will be exchanged between hot fluid and hot fluid to the cold fluid. So that is called as a heat exchanger. So we can define heat exchanger as a device in which heat exchange will be takes place between two fluids which are at different temperatures. Now, what is the application of heat exchangers? So heat exchanger will be found in many industries. So the industries include, one is chemical industries. Heat exchangers will be used. Petrochemical industries. Next, in oil and gas industries. Power generation, that means a thermal power plant, nuclear power plant, and other power plants where boilers and turbines and condensers will be used. No? So in that also heat exchangers will be used. Refrigeration, so in refrigeration also evaporator, condenser, and other device will be there. So there also heat exchanger will be applicable. In pharma industries, no pharmaceutical, their heating and cooling process are there. So there also we need application of heat exchangers. HVAC, heating, ventilation, air conditioning systems also we need heat exchangers. Food and beverage processing. No, in food and beverage processing, there is heating and cooling of food and beverage is required. For that, people will be using heat exchangers. Pulp and paper industries also people will be using heat exchangers for heating purpose as well as cooling purpose. So these are some of the examples of heat exchangers where people will be using heat exchangers. So next you come to the classification of heat exchanger, how the heat exchanger will be classified. One is according to the heat exchanger process. One is based on direction of the fluid motion. The other one is design and construction features. Now we can classify the heat exchangers. And last one is based on the physical state of the fluid. Like this, we can classify the heat exchangers. First, you take the nature of heat exchanger process. Based on nature of heat exchanger process, no, heat exchangers will be classified as indirect contact and direct contact. Direct contact and indirect contact heat exchangers. So, in case of direct contact heat exchangers, no, both hot fluid and cold fluid will be directly contact with each other, thereby cooling. I mean, heating process will be happening. So, best example will be cooling tower. In cooling tower, no, hot water will be taken to the certain height, and it is dropped so that that will be cooled with help of atmospheric or surrounding air, cold air. So that is called as cooling tower. Similarly, jet condenser also. In jet condenser also, steam will be cooled with help of cold fluid by direct contact with each other. So when both fluids having direct contact, then it is called as a direct contact heat exchanger. Next one is indirect contact heat exchanger. So here in indirect contact heat exchangers, so both hot fluid and cold fluid will be separated. Indirectly, it will be heat will be transferred. Best example will be regenerator. So in regenerator, the hot fluid and cold fluid will be so periodic flow type of heat exchange will be happen. For example, you take the example of air preheater. So in air preheater, no, a meshing type space will be there. Initially, we will send a hot fluid so that the space will be get heated. Then we are sending cold fluid so that cold fluid will be get heated with help of the mesh which is already heated. No, like that it is periodically happening heating and cooling process. No, so that is called as indirect contact heat exchanger and regenerator. One more example for this direct indirect contact heat exchangers will be recuperators. The recuperators are called as surface heat exchangers. So in case of surface heat exchangers, the hot fluid and cold fluid will be separated. Separate paths will be there. The separate paths for each hot fluid and cold fluid. That means hot fluid and cold fluid will be separated by means of walls, surfaces, circular surface or rectangular surface, whatever may be the surface. Then the type of heat exchangers is called as surface heat exchangers. So majority of the heat exchangers will be comes from this kind of indirect contact heat exchangers. That too it is surface heat exchangers only or recuperators only. Surface heat exchangers or recuperators only. Next thing is based on relative direction of motion. Based on relative direction of motion, heat exchangers will be classified as parallel flow heat exchanger, counter flow heat exchanger, and next one is cross flow heat exchangers. So these are the three classifications we are having under based on the direction of motion. Based on the design and construction features, no, it will be classified as a concentric tube. Concentric tube means a tube in tube. So a large tube will be there. Inside a small tube will be there. Inside one fluid will be flowing. And the annulus portion, other fluid will be flowing. So that kind of heat exchanger is called as here hot fluid. Hot fluid will be flowing. THI. Here hot fluid will be coming out. Surrounding will be cold fluid, annulus portion TCI, and here TC naught. So this will be the concentric tube exchanger. This is a concentric tube heat exchanger or tube and tube heat exchanger. Next one is shell and tube heat exchanger. For that separate diagram will be there. I will show that one. Next one is multi-shell and tube pass heat exchanger. Number of tube passes and number of shell passes will be there in the heat exchanger. Next one is compact heat exchangers. So let us see this one based on the direction of motion. No, will have parallel flow. Parallel flow means this is the hot fluid THI. This is the cold hot fluid outlet TH naught. Here this will be TCI. Here it will be TC naught. So if you see, both hot fluid and cold fluid will be travels in the same direction. That's why it is called as parallel flow. And it is since it is tube and tube, it is called as a concentric tube heat exchanger. So in this case now, second case, this is THI and this is TH naught. And if you see now, TCI is entering TCI and this is TC naught. Since this is hot fluid direction, TH direction, this is cold fluid direction. So since both will be traveling in the opposite directions, that's why it is called as counter flow or opposite direction, no? Counter flow heat exchanger. Next one is here, both hot fluid and cold fluid will be travels in 90 degrees. This is traveling this direction and tube flow will be in this direction. Both will be having 90 degrees now. That is called as a cross flow heat exchanger. Here the fluid will be separated by means of plates. Here the fluid is separated by means of tubes. No, that's why it is called as both fluids will be unmixed type. This is both fluid will be unmixed type. So here now the cross flow will be there. It is mixing type because after entering once again it is mixing here. Whereas tube flow now once it is entered it is unmixed type. Unmixed type. Tube flow is unmixed type. Therefore, it is called as one fluid mixed and the other will be unmixed type cross flow heat exchanger. So, like this, we can classify the heat exchanger based on direction of motion. Next one is shell and tube heat exchanger. Shell means is a large cylinder. Shell means large cylinder. Next one is inside now number of tubes will be there. Inside number of tubes. Inside number of tubes will be there. A large cylinder, inside number of tubes will be there. So when heat transfer requirements is more, no, we cannot use heat exchanger so length. We cannot because of space constraints, because of material constraints, and because of other restrictions. Now we cannot go for very long heat exchangers for high heat transfer rates. So in such cases, no, people will be using shell and tube heat exchanger for larger amounts of heat transfer rates. For that, people will be preferring a shell and tube heat exchanger. So this is called a shell and tube heat exchanger. So it consists of a large cylinder. It is called as shell. Inside tubes will be there. It is called as a tube. The fluid which is flowing in the shell shed is called as shell fluid. The fluid which is flowing in the shell is called as shell fluid, that is surrounding the tubes. The fluid which is flowing in the tubes is called as tube fluid. So there are two fluids will be there. Next one is baffles will be there. Baffles will be there. So which will be used for creation of turbulence. Creation of turbulence in the shell side. The shell side show that better heat transfer will be takes place between the two fluids. So shell fluid will be entering here. Shell fluid will be entering here. It is traveling like this. It is traveling like this, and it is coming like this. So that is called as entering one side and leaving other side is called as one pass. One shell pass. Entering one side and leaving other side now of the heat exchanger, it is called as one shell pass. Tubes also. So two fluid will be entering here, and it is flowing in the number of tubes. It is flowing in the number of tubes, like this number of tubes. So and leaving this side. So tube fluid also entering one side and leaving other side now. That is called as one tube. One tube pass. One tube pass. So the name of the heat exchanger is one shell pass, and one tube pass heat exchanger. So like this we can name the heat exchanger based on the cell pass, based on the number of tube passes. Next one is, if you take this one, this heat exchanger is shell fluid will be entering here. Shell fluid will be entering here, and it is flowing like this. This is one shell pass, and it is coming like this now. This is called as one shell pass. Coming to the tube pass, it is entering here. It is going like this. Once again coming like this. So when it is coming this one, you will get one tube pass. When it is coming this one, you will get the two passes. Therefore, the name of the heat exchanger is one shell pass two pass heat exchanger. For example, if you take now this heat exchanger, it is entering here and it is leaving here. That means when it is comes this side now, that is called as one shell pass, and it is coming like this now, two shell pass heat exchanger. Coming to the tube pass, tube will be entering here. Tube will be entering here. This is entering here, and it is going like this. One tube pass. When it is coming like this now, two tube pass. So when it is coming like this now, three tube pass. When it is coming like this now, four tube pass. Therefore, two shell pass and four tube pass shell and tube heat exchanger. So like this shell and tube heat exchanger. So like this, based on the number of shell passes, based on the number of tube passes, we will get the name of shell and tube heat exchangers. So that is about the shell and tube heat exchanger. Next one is we are having compact heat exchanger. So compact heat exchanger means it has a larger heat transfer area per unit volume. So best example will be car radiator. Car radiator will have a larger surface area per unit volume, as well as human lungs also. No, so these heat exchangers with the area density less than greater than 700 meter square per meter cube is being called as compact heat exchangers. And last one is what is the last one is a boiler and a condenser will be there. Boiler is a one type of heat exchanger, and condenser is one type of heat exchanger. Boiler means one fluid is cooled, the other fluid will be condenses as it flows through the heat exchanger. So here phase change will be happening. Phase change will be happening. Phase change is happening from liquid to from vapor to liquid at saturation temperature. at saturation temperature. So what is happening actually in condenser now, we are removing the latent heat. When latent heat is removed from the vapor now, the vapor is converted into liquid. Phase change will be happening at saturation temperature. So the definition of condenser is whenever vapor, saturated vapor comes contact with the surface which is maintained at low temperatures, then condensation will be happening. That means vapor to liquid will be happening, phase change will be happening. So it is a special type of heat exchanger. Similarly, boiler is also a special type of heat exchanger where phase change will be happening from liquid to vapor. So whenever saturated liquid comes in contact with the surface temperature which is maintained at high temperatures now, then boiling will be happening. So that means phase change will be happening liquid to vapor, that is called as boiling process. Generally it is happening at saturation temperature or more than saturation temperature. So this is called as boiling process. So it is a special type of heat exchangers where phase change will be involving. Phase change will be involving. So like this, all the heat exchangers will be classified. One is based on based on based on contact, direct contact and indirect contact will be there. So based on direct contact and indirect contact, heat exchangers will be classified. Next one is based on relative direction of motion. Now, this is first one is direct contact and indirect contact. Second one is parallel flow heat exchanger, counter flow heat exchanger. Next one is cross flow heat exchanger. So like this, based on the direction of motion, we can classify the heat exchanger. Based on the design construction, concentric tube heat exchanger, shell and tube heat exchanger. Next one is compact heat exchanger. Next one is like this, it will be classified. Next one is based on the physical state of the fluid. Now there will be boiler will be there. Next one is condenser will be there. So these are the classification of heat exchangers. So I hope you understand this concept of classification of heat exchangers. So for more videos now, you can click on the subscribe button on the right side bottom of the video. You can get the more videos from my channel. Thank you for watching this video. I am Dr. Hari Prasad, Professor of Mechanical. This is email ID and phone number. You can contact me for further questions and feedback. Thank you.